In this video, I explain how to use the 7-point miscellaneous factorization toolkit to cancel some algebraic fractions. So, first question is this one. Scanning down the list, it's not a difference of two squares because there's no subtraction sign and there aren't two terms. I'm working on the top here, by the way, at the moment. Common factor, there's no common factor in any of these four terms. That rules out these. It's certainly not an easy reverse smiley. This is quite complicated. And it's not a hard reverse smiley. I'll explain what they are in a second. But it could be a general two pairs because there's two terms there. Okay. Now, what about the bottom? Well, that is a hard reverse smiley. A hard reverse smiley is when you suspect that it's going to end up just being brackets like this with, something like that. I mean, this is just an example. What makes it hard is that that's a 2, which means there's more combinations to muck around with in these brackets. So anyway, let's work on the top. Because there's four terms, I'm going to try seeing if it can fit the general two pairs template. In this, you treat this and this as two separate questions. It's got a common factor of x squared, and this has a common factor of 2. Just treat them as two separate questions. Now, what makes that great is that this is now a common factor. So whatever you see twice, those 5 characters write once, open up a bracket, write what it used to be with, and that's now the answer. I'm now going to work on the bottom. What we do is we imagine that the negative 8x came from somewhere. Could have come from 10x minus 18x, could have come from minus 5x minus 3x. Of all the places where it could have come from, what Ms. McKeever recommends doing is picking a combination where the two terms that lead to this have the same product as those two. In other words, negative 20. And that's easy enough. Let's imagine that came from plus 2x minus 10x. And then this times this is the same as this times this. So you now treat this as a two-pair question. So that has a common factor of 2x. And that has a common factor of negative 10. And now I see a common factor of bracket x plus 1 bracket. Open up a bracket, write what it used to be with. And now I cancel those. And so that's the answer to question 1. Question B, the top is quite complicated. Doesn't fit any of these templates. So I'm just going to use Dear Mr. Examiner. I'm going to just show off a skill. That skill is expanding. Now, I'm going to use the strategy where you think what's special about the situation, what looks like it's not an accident. It's probably not an accident that matches that, and in fact that enables me to cancel that out. Now, looking down my list, the two pairs technique could be good here because there's 4 terms. Treat that as a question on its own. Treat that as a question on its own. That's got a common factor of y. Now, the reason why I've chosen negative y rather than positive y is to enable me to write this, which is the same as that. That now means there's a common factor of bracket 2a minus b bracket. Write that once, open up a bracket, write what it used to be with. Now I can concentrate on the bottom. Now, it's certainly not common factor. There's nothing common to all of those. It's not difference of two squares. There's just two terms in a difference of two squares. Now we've got squared business there and squared business there, but for difference of two squares they need to be subtracted and this cannot be present. But in fact that makes me realize that it might be the reverse poem, because the poem for expanding a square says square the first, square the last, twice the product of the first and last. And that's what's going on here. That's something being squared. That's something being squared. Now let's hope and pray that that's twice the product of what I just wrote. The product of what I just wrote is negative 2ab, and that's twice that, so it's good to go. And that enables me to cancel this and this, so the answer is that. That's very complicated, doesn't fit any of these templates, so I'm going to use Dear Mr. Examiner. I'm just going to show off the skill. Just expand those brackets. Try and spot something that's not an accident. It's not an accident that that and that have been put in there. The question designer made it like that. They're in fact the same, so you can cancel them out. And now you have 4 expressions, so it's good to use the 2 pairs, or good to try technique 5 for general 2 pairs. So treat that as a year 8 common factor question. Now the whole idea is that we want that to appear again. Oh look, it does. Common factor of C. I spot those 5 characters twice, write them once, open up a bracket, write what they used to be with. Okay, now I can concentrate on the bottom. There's a common factor there. Now just because it's factorized doesn't mean it's fully factorized. It's good to have as many factors as possible. Could I factorize this? Well, that's a classic difference of 2 squares. There's a squared thing, there's another squared thing, and there's a minus in between. So you write the same bracket twice, once with a minus, once with a plus. And now you cancel that out. So that's the answer. The top certainly doesn't have any common factors. That's not an option. It's not a difference of 2 squares. That's when there's 2 terms. This has 3. It doesn't look like it's an easy reverse smiley or foil. That's because of the cubed term. Easy reverse smiley is just for things like this or like this. It's certainly not a hard reverse smiley. That's the same as the easy reverse smiley. It's just that you've got things like that at the front. It's not general 2 pairs because there's 3 terms, not 4. It's not the reverse poem. The reverse poem is when you spot that the squaring a bracket poem has been applied, which means by a process of elimination it has to be the division method. Now the division method says that in algebra you get the same thing as in ordinary numbers. If you're trying to factorize, I don't know, 1001, if you divide it by, I don't know, 13, and you succeed in getting a whole number, so for example you get 77, then you can factorize the number that you divided by. This is because division and multiplication are 2 sides of the same coin. So 10 divided by 2 equals 5 is the same as saying 10 equals 5 times 2. In other words, if you succeed in a division, you have achieved a factorization if you write it in an alternative method. So we're going to divide this by an algebraic expression and hope that we get something without a remainder, because then we will have factorized it. And what this method says to try first is something of this form. Try dividing that by something like this. And what you should try in that box is any number that you can succeed in making this 0. And just try the regular numbers first, like 0, 1, negative 1, 2, negative 2. Don't waste your time. If it's going to be factorized, you're going to need to get a negative 6 through expansion, so don't try 5. 5 can't be times by anything to give negative 6. Try numbers like 2, 3, 1 and 6. So I'm going to try 1 first, so that will be 1 cubed is 1. 1 take away 7 is negative 6. Take away another 6. That doesn't come out to be 0. Let's try negative 1. That'll be negative 1 times negative 1 times negative 1. That's negative 1. That'll be positive 7. So negative 1 plus positive 7 is 6. Take away 6, you get 0. So I'm going to try dividing by that. And this is me dividing by that. That space is to help me line everything up nicely. Okay, so that divided by that is that. That times that is this. I'm going to go through this quite quickly. There's a separate video available on how to do these divisions. So I go, that divided by that, get this. Do that times that, write it there. Now also do that times that, write it there. And now subtract. That take away that is blank. That take away that is negative x squared. Copy this fella down. Now go, that divided by that, negative x. That times that, negative x squared. But also do that times that, which is negative x. Subtract. That minus that is blank because they're the same. That minus that, take away negative is adding, so it'll be negative 6x. Okay, bring that down to continue the process. That divided by that is negative 6. That times that is negative 6x, of course, because that's where it came from. Negative 6 times 1 is negative 6. Subtract those and you get a remainder of 0. Just like succeeding in dividing 1001 by 13 and getting 77 enables you to write 1001 equals 13 times 77. When we divided this by that and got that, that means that this expression is equal to x plus 1 times x squared minus x minus 6. And copy down the bottom. Now, more factors are better than fewer, so let's see if we can keep going. That there is a easy reverse smiley. So just set up a couple of brackets, see if you can make something work. That certainly works. Negative 3 times 2 is negative 6. The nose would be negative 3x, the mouth would be 2x. They combine to give negative x. Now, what about the bottom? That's a common factor of 5. And that's now the difference of 2 squares. Patiently copying out the top. The whole point of difference of 2 squares is that you write the same bracket twice, once the plus, once the minus. And check this out, get to cross that off, get to cross that off, and there's your answer. A hard reverse smiley, because it could so easily have come from just double brackets. All we need is a 2 and a 1. What makes it hard is that the 6x squared gives us a fair few combination. Is it 2x and 3x, or is it 3x and 2x, or is it 6x and 1x? Just a whole pile of pain. So we kick in Miss McKeever's 2 pairs method. What she says is to imagine where 7x came from. Did it come from 3x plus 4x? Did it come from 2x plus 5x? Of all the combinations that it could have come from, pick a combination where the two things you write down give the same product as this and this. So we need a product of 12. Oh, there we go. 4x and 3x is perfect, because 4 times 3 is the same as 6 times 2. Now do it as 2 pairs. Treat that as a year 8 question. It's got a common factor of 2x. Open up, write the common factor, open up a bracket, write whatever it takes to make your 6x squared appeared upon multiplying out the bracket. Now for this one, do an artificial common factor of 1, because that enables you, oh sorry, I forgot to copy this out. Because that enables you now to spot a new common factor of these 6 characters. So I'm going to write those 6 characters once, open up a bracket just like a year 8 would, and write what it used to be with. I can now concentrate on the bottom. The bottom is same thing. Okay, so where could negative x have come from? We'd like a combination which gives the same product as 10 and negative 3, so negative 30. let's imagine it came from positive 5x and negative 6x. Now treat it as two pairs. So common factor of 5x there. Common factor of minus 3 there. I know I could have had a common factor of just ordinary 3, but I'm trying to achieve a repetition of this factor. So I see something twice, write it once, open up a bracket, write what it used to be with, and there we go. Now, we've got the common factor of y on the top. We've also got a common factor of y on the bottom. So let's open up a bracket, write what we see multiple times once, and write in the bracket what it used to be with. Same on the bottom. And in fact, collect like terms at the top. And the top is the same as the bottom, so the answer is 1. Okay, so what could this question be? Well, the bottom is straightforwardly difference of two squares. I'll tackle that first. The squared thing minus squared thing. So what do? Write the same bracket twice. Once for the plus, once for the minus. For goodness sake, check b times b is b squared, 3a times 3a is 9a squared. Now let's tackle the top. Now, what could this be? There's no common factor. There's nothing common to all those three expressions. It's not difference of two squares. It's certainly not an easy reverse smiley FOIL. In general, hard reverse smileys look pretty straightforward. They look like this. Not anything as complicated as that. Can't be general two pairs because there's three terms, not four. Certainly not the reverse poem because I can't look at it and say that there's two squared expressions. Yeah, there's no squared expressions there, and certainly that can't be a squared expression as long as there's a negative. And the division method for polynomials doesn't seem to apply because there's more than one letter. So basically this thing that I skipped over here, hard reverse smiley, that has to be it, just by process of elimination. In other words, it had to have come from something like this, where, I don't know, negative 3b and b gives the negative 3b, and maybe, I don't know, 2a and 6a gives the 12a squared, but that times that and that times that does not give 5ab. So we're going to use Ms. McKeever's method to get this more efficiently. Okay, so what we do is we imagine that that came from somewhere. It could have come from maybe 2ab plus 3ab or 1ab plus 4ab. Ms. McKeever says, of all the places could it come from, think of some combination that gives the same product as 12 and negative 3, which is negative 36. So, where could 5 have come from? It could have come from, how could we get 36? Negative 36. Could come from 12 and negative 3, could come from 6 and negative 6, could come from 18 and negative 2, could come from 12. I've already done that. What else could it have come from? Could have come from 36 and negative 1. Must be missing something. Oh, there we go, 9 and negative 4. There we are. Right, and that's perfect because 9 AB and minus 4AB. That times that is the same as that times that, which is sweet. And 9 take away 4 is certainly 5. So we're good to go. We now do it by 2 pairs. Treat that as a Year 8 question. It's got a common factor of 3A. Open up a bracket, write what it used to be with. This has got a common factor of negative B. Open up a bracket, write what it used to be with. Spot the common factor, write it once. Open up a bracket, write what it used to be with. And then if you can, cross those off. So that's done. Denominator is difference of 2 squares, so write same bracket twice, once to the plus, once to the minus. The top, it's got a squared thing and a squared thing, so it could come from the poem. Maybe came from this. But because there's a minus there, let's investigate whether it came from that. Square the first, you get that. Square the last, you get that. Twice the product of the first and last is that, so it's good to go. So that's the answer, and now you cancel out that and that. So the answer is A minus B over A plus B. Let's look at the top. Certainly not common factor because there's nothing common to all those. Difference of 2 squares can't be that because there's 3 terms, not 2. Certainly not an easy reverse smiley. Doesn't look like it could be a hard reverse smiley, but obviously I have to keep an open mind on that. It can't be general 2 pairs because there's 3 terms, not 4. It's not the reverse poem because there's nothing being squared. Maybe it's the division method. Let's see if that works. The division method says that it's worth trying to divide that by something because if you succeed, my example of if you succeed in dividing 1001 by 13, then it enables you to factorize 1001 as the product of the divisor and the quotient. So it's worth trying to divide this by something. Now it's worth trying to divide it by this template where the box is filled by whatever you succeed in substituting into this and getting the number 0. Just try basic numbers that have some chance of multiplying to give 8 if you expanded your factorized expression. So I'm talking 1, 2, 8, 4, -1, -2, -4, -8. Just try them in the most obvious order. If we put a number 1 in there, you get 0, so it's sweet. So it's worth dividing this by A minus 1. So that's what I'm going to do here. A minus 1 is going to be divided into this. I'll leave a gap there to make it all line up nicely. Now, you can watch a separate video on how to do this division. I'm just going to go through this quickly. That divided by that, 2a squared. That times that, 2a cubed. That times that, negative 2a squared. Subtract. That minus that, blank. That minus that, 8a squared. Repeat the process. That divided by that is 8a. Go that times that, 8a squared. That times that, negative 8a. Subtract. That minus that, blank. That minus that, positive 8a. Copy this down. Repeat the process. 8a divided by a is just plain old 8. Do that times that, 8a. That times that. Subtract, you get 0. That was great. It means that just like there's no remainder when you divide 1001 by 13, there's no remainder when you divide this by that. Just like it enables us to write 1001 as a product, we can now say that the numerator, this thing here, is a product. It's a product of what we divided by and what we got as our answer. So we've now factorized the top. Now, we're not done yet. Maybe this can be factorized more. It certainly can because there's a common factor of a 2. Which item could that be? I'm pretty sure I can factorize that some more. That's a reverse poem. I see a squared thing. I see a squared thing. So let's try it out. could it be this? Square that, you get this. Square that, you get this. The product of those is 2a, and there's twice the product of those, so it's good to go. Now the bottom is the harder reverse smiley face. So we're going to try and split that up into something that has the same product as this times this, which is negative 63. Okay. So negative 63 can be 3 times negative 21, or 1 times negative 63, or what else could it be? 7 times negative 9. 21 times negative 3. Oh, in fact, there it is. That's the one we want, because that plus that gives 18. So we're imagining the 18 came from 21a minus 3a, and now we're good to use the 2 pairs method. So treat that as a U8 question. I see a common factor of 3a, open up a bracket, write what it used to be with. I see a common factor of negative 3, open up a bracket, write what it used to be with. I now see a common factor of those 5 characters, bracket a plus 7 bracket. Write that common factor once, open up a bracket, write what it used to be with. Now, that has a common factor. And now cross those off, and you're done.